Welcome to Inside Exchange, Topics for Manufacturers, a series bringing you expert-led presentations on the issues that matter most to members. The curated topics in this series feature presentations from associate members and subject matter experts through on-demand and live webinars to help Hudson Valley manufacturers. If you have topics you'd like us to explore in future episodes, contact us at info@councilofindustry.org. Let's begin.
Hello, everyone, and welcome to Inside Exchange. I'm Johnny Ann Hansen from the Council of Industry. I'm thrilled that you decided to join us for today's webinar. Today, we're going to talk a little bit more about the blurred lines between IT and OT. In this interconnected world, we know that our members are more vulnerable than ever. Recently, we have been hearing about cyber attacks from our members more frequently. What seemed like it was once in a while is now almost on a weekly basis. We know that our members know that it's important, but we're hearing that it's overwhelming and it's hard to know where to start. Hopefully, our presentation today can help give you a little bit of guidance and start the conversation. As a reminder, this is always just the beginning of a conversation, so feel free to reach out to us, to reach out to Florian, and to just keep the conversation going. Send us your recommendations of other topics that you might think are important. Today's presentation is by Florian Doumenc from Trout Solutions. Trout Solutions is an associate member based in Kingston, New York. They specialize in creating purpose-built connectivity solutions for factories, and will share strategies to ensure compliance, enhance data protection, and improve traceability. Hi, Florian. Thank you for doing this today. Why don't you get started with telling us a little bit more about Trout Solutions?
Sounds good. Thanks, Johnny Ann, and thanks to the Council of Industry. Really a pleasure to spend some time here. So Trout, we're a family business based in Kingston, and we manufacture equipment to then digitalize factories. So it's hardware that are installed in factories to help on digitalization and security. And so the goal of today is kind of to do some of the webinar with our learnings from them over the years around really building a secure and compliant factory network, which is kind of the foundations of all that digitalization. So 25 minutes, a bit technical, but hopefully not too much. And yeah.
That's great, Florian. So we appreciate you taking the time to do this. I know that many of our listeners have inquired about these types of topics, so I know that it is relevant, and I'm going to let you take it away.
Sounds great. So the structure of the webinar is kind of to chat a bit about IT and what we call OT, operational technology, and then moving into usually what we see in terms of traditional network and how they build and their security. Before chatting about zero trust, that's kind of a big term that you might have heard in terms of security, and trying to clarify what the meat is around this, and before moving to more like practical implementation and conclusion. So that's the agenda. And one thing as we go through that webinar is to keep is this customer. That was basically the first customer we worked with. As you can maybe hear from my accent, I'm from France. I'm from this town. It's a beautiful ski resort with an excellent view on the Alps, on the Mont Blanc, sorry. And so the first kind of implementation we did with them was to help their IT manager manage that network, a network that's pretty big because we're talking about more than hundreds ski lifts and geographically dispersed. And really to think about how you can reduce the network complexity, how you increase the security posture, as well as the visibility to get a sense as the IT manager of what's happening on my network, who's talking to whom, and that type of behavior. We also have customers in the or partner in the Hudson Valley, but this one is close to our hearts, as you can imagine. So starting with really what is IT, what is OT? IT basically has eaten most of the world. That's kind of the what we've heard for some time. But what we mean by OT and what people refer to as operational technology is everything that's pretty much on the shop floor, from control system to camera to badging, to HVAC to scanners and so on. So it's really all the equipment that used to be analog and kind of became digitalized, and that now fall under this umbrella of operational technology. On the other side, you can think about IT as all the computers and all the phones. That's what we would refer to as traditional or like more IT. When we look into security and how we can secure both perimeters, so the IT and then the OT, there's this a set of tools called EDR, or sometimes we refer to as antiviruses, that are really, really good at protecting IT environments. So you install an EDR on your phone, on your computers, and you pretty much guarantee that you're going to have a good protection in there. When we talk about protection, there's some caveats there. I think we can still do some CrowdStrike jokes, but that there's some risk in terms of what you can do with EDR too. But that's more a turnaround. So when we look into non-IT and operational technology environments, it's way more difficult to deploy an EDR. Most of them, we're dealing with machines that have been bought and shipped by the vendor, and you don't have access to them. You cannot install extra software. You cannot really configure the security of them, or you can configure the settings, but not add things of your own. That's the first kind of big difference. The second one is that those systems have been built with this notion of air gap. They were not really supposed to be connected to the internet, to the World Wide Web, but much more for like local network. And so the level of security or the way security has been built is different. And often we find a lot of like vulnerabilities and weaknesses in those machines that have been built with kind of another paradigm in mind. And the last thing that's really interesting to see is that when you talk about IT, a computer and a phone, you have a human using them, and they can do a lot of crazy things or a lot of different behaviors. And so you need to protect against that. Versus when you have an operational technology, it's way more, there's a limited set of behaviors that you know well, and you should monitor for that. So what you're protecting against is really different. It's more an old machine that does a couple of things versus new machines where you have a human doing a lot of different things. So that's why like there's a distinction in terms of security and connectivity between IT on one end and operational technology on the other side. So the way we secure IT, as I mentioned, is about the EDR, the antivirus is adding a little piece of code on that machine to protect it. When we look about operational technology, it's much more how you build a network and how you connect them to the assets that are around. That's going to be the right way to approach that. And so the goal of this webinar is kind of to double click on how you can build that network so that it's secure, it's compliant, but at the same time you can move and you can deploy new technologies around those assets. So when we look at traditional network security, and that's the case because we've been into now close to 100 of sites, and those truths we still see them most of the time. Is that most of the network still rely on a single point of failure or a single edge, often a firewall. And with this idea that once you're in, trust is assumed. So you're in the network, you're in the building, then you can access everything. That's really a risk. That's something we'll see later on. And the main reason why is that often when you have IT, it's easier to get a malware on IT through phishing, through that type of attacks, that then spread to the rest of the network and kind of clog the whole system with a ransomware, with some attacks that we see a lot like this. So this notion of once you're inside, you have full access, you have full trust, is kind of something that's really problematic. The second thing that we see a lot is this culture of it's working, we're not going to touch it. And often when we go into a network cabinet, there is like some cables that we don't really know where they're going, or there is kind of like old boxes and network equipment that have been not unplugged because we're not sure about what they do. And so that's a kind of culture that we also need to challenge. And see this network much more as something dynamic that could be changed, that could be refined, and that's going to change a lot the security and the compliance of it. Other things that we see really in usual networks is kind of performance bottleneck. Once you reach certain levels, the way the network is structured around VLANs, for example, creates a lot of bottlenecks and decrease the performance, which is problematic when on one end you kind of have high demand video calls, and on the other side you have kind of more legacy machines, but then the structure of Ethernet and the way it works makes everyone go at the same pace. And so that's kind of one problem that we see pretty often. And the second one is around this layer 2, layer 3 distinction and how we can secure them. That will double click on at that moment. But still, like this notion of once you're inside, it's trusted should be challenged. This notion of if it's fixed or if it works, don't fix it, should be also a bit challenged, and that's going to help address the performance, the security, and the compliance of network. So getting slightly more technical on that slide, and after we'll go back to a higher level. There's a couple of terms that we talk about in networking and in security. This notion of north-south versus east-west. East-west is really two machines or two assets talking to each other on the same network. When north-south is talking to the internet, it's going to the cloud, it's going to a server, it's going to Azure, for example. That's a typical north-south behavior. What we see is that most of the IT systems, so the computer, the phones, and so on, have moved to like 95% of their transaction being north-south, or their communication being north-south. When we're looking at OT, they're on the other side of the scale. Most of the communication are lateral. And the main reason why is for security reasons. You don't want to expose your machine to the World Wide Web because they haven't been built this way. And so you need to kind of structure them and protect them in a different manner. And so slightly technically is that basically when you talk about north-south, you're talking about packets that are routed or communication that are routed, that go through routers and that work with IPs and so on, which are technology at the layer 3 of the OSI stack. Versus when you're in the east-west, most of the time you're working about Ethernet data frames that transit on the wire. And so it's kind of the level below. You do not go to the IP to create some logic, you stay at the level below. And that allows you some speed, but also some challenges in terms of security. And that's why there is a distinction that's really different. Layer 3 has been built around this idea that you live in an untrusted environment, and so you need to do different hops, versus layer 2 is much more, you are actually on the same wire. So dealing with the complexity of layer 2 versus layer 3, what we tend to recommend when we look at a site is really to clarify who does what. And to say the layer 2, which is basically the Ethernet cables that you plug, should be dumb, fast, and simple. It's much more like I'm pulling a cable, I'm connecting my devices, my access point. It goes to the main switch, and that's it. Don't spend too much time building logic at that layer. You can use the layer 3 to build more that logic, the flexibility that you want on top of that. So that's kind of what we recommend usually when we're going to site, this distinction of layer 2, dumb, simple. Layer 3, start to build some routing, some segmentation mechanism, because that's the right place, or we strongly believe that's the right place where they should be. And so what that done, or what happens is pretty much this, is that you have this layer 2, which is dumb frames that move on the wire, versus layer 3, where you create those IPs and routes of like these machines are there, and then you can talk to each other with direction, pretty much knowing where you should talk to them. The main advantages of that structure is that you can do routing, as I mentioned a bit, with directions, with IP, or you can also work with proxy mechanism. And those proxy mechanisms are ways basically that between two machines that talk to each other, you put a little buffer or a third person that's just going to be a man in the middle and look at what's said. And that allows a lot of security best practices and compliance best practices this way. So that's why this notion of proxy is really interesting at the layer 3. So one of the feedback we hear about this kind of structure is that as you're moving packets and analyzing them, that creates a lot of what we call overhead or additional computation. The good thing is that the hardware has evolved in a way over the last 20 years and 30 years that it's not a bottleneck anymore. And you can process a lot of the packets, especially when you look at east-west traffic without any bottleneck and issues on that regard. So it's one of the things. One of the other things that I need to find a 2024 image. So if anyone has something like this, I'm keen to see. Okay, so here some of the hot tech, and I think that's probably the main hot tech from this webinar. What we really recommend and are strongly opinionated about is that VLAN should not be used for network segmentation. So VLAN is a way to, at the layer 2, to apply some logic and to kind of cut the wire saying like, this is my VLAN IT, my VLAN OT, my VLAN camera. What we're saying is that this is a really bad tool to solve the problem because you don't have visibility, because it adds a lot of complexity in terms of managing that. Most often it reduces the performance because you're actually putting a lot of assets on the same LAN that talk to each other when there is no reason they should, not because cameras are cameras that they should talk to each other, for example. And yeah, there's this sense that virtual lines are a way to provide security, which is most often not the case, because at the end of the day, you're going to start to create some routes or some communication between them. And the networks end up being flat and attackers being able to move around and really lock down the whole site when they succeed on an attack. So that's the main thing we really recommend and kind of challenge people about, is that VLAN should not be used for network segmentation. I'll share my email, and if there is strongly opinionated people on the other side, I'm happy to have a discussion about that. As I mentioned, so we're strongly opinionated. We're not the only ones. So Cisco is pretty well known in the world of switches and communication, and their recommendation is exactly this: VLAN should be locally on switch and should not span across multiple switches. So you shouldn't have multiple switches across, for example, a factory, sharing VLAN and kind of interconnecting asset because they are in the same topology. So what can you do with VLAN and how you should use them? Our best practices is really to say we will have two different VLANs that we do not use for network segmentation, but that we use for addressing. One is VLAN 10. You can use the number you want, but that's kind of the best practice we recommend, where you put everything that's IT based. And what we mean by IT is what we mentioned at the beginning. You can also think about this as everything that can either move or go to the trash. If I have an old laptop, an old phone, and I can just like throw it to the trash and then get a new one, that falls into the kind of IT VLAN addressing and use case that you should have. For that VLAN, what we recommend is to use protocol or configuration like DHCP, which is basically whenever there's a new device that comes on the network, it's going to give me an IP and a set of configuration, and I can talk to the internet most of the time, but also to other potentially assets on the network. That's a dynamic asset. If today I lose my phone and tomorrow I come with another one, there's a new IP copy, and so on and so on. So that's kind of the VLAN IT dynamic that you should set. On the other side, there is this kind of VLAN OT, operational technology. These are pretty much things that don't move. So server machines are fungible in terms of data, but also scanners and so on. What we recommend is that on this one, you do not set DHCP. DHCP is also an extremely weak protocol where you can have some attacks. So that's why we recommend not adding it into this environment and to rely much more on static addressing. You know your machines, they have a specific IP that doesn't necessarily rotate over time. Most of the machines also you have configure an IP in them. So that's the right way to use that environment. And so that's kind of how you have your network. What we recommend is also to configure this VLAN as private VLAN. Sometimes we talk about no neighbors or port isolation, which is even though I'm in the VLAN 20, I am not able to talk to the other with just the MAC address. I need to go to the layer 3 to the head of the LAN before coming back. And that avoids, again, a lot of lateral movement that we see as so damaging when we have a ransomware. Yeah, so 2 VLANs use more in terms of addressing and structure versus network segmentation in that regard. So how do you then scale the kind of the connectivity and the factory? What we recommend is to build what we call group of assets. Sometimes it's also referred as zones, and then to control access to each of the zones. So if you have on the shop floor a set of machines that are kind of in the same task or team, then you can group them together and control access to those machines at the zone level. It's also to enforce a best practice in terms of security, which is this least privilege access. By default, you're going to have the least amount of permission that you really need to do your job. So avoid to do or to give admin access and kind of wide open permission when it's not needed. And the right way to apply that onto a network is to cut it into specific zone, where you can have that granularity. Saying, yes, that user, that machine can do these things on my drilling zone, for example, but cannot do the same when it's about the logistic or the scanning or the data room, for example. One of the things that we recommend, and that's kind of more in terms of compliance, even that it's a requirement, it's about authentication, users and machines. So it's making sure that, yes, it's usually me, Florian, who's accessing the laptop in the shop floor, or it's this laptop that's then accessing our data server on premise and stuff like that. So making sure about who does what action and authenticating that as much as we can to a user, to a machine. And then the final step of once you've created your zone, control access to them with least privilege and authentication, is then to just monitor and being able to verify that everything is going according to the plan. Once you have all of this together, the network is already in a better shape, and you can deploy much more quicker some technology. So one term and one concept that's interesting to think about is this notion of micro DMZ or demilitarized LAN. If you have some knowledge of IT, you're pretty familiar with this notion of DMZ. A DMZ is a concept that comes from the military. It's a demilitarized zone between untrusted, which is the internet, and trusted, which is the internal network. As we've mentioned, that notion of untrusted versus trusted has been a bit shattered. And now that you have computers that always go to the outside, to the internet and so on, they should not be considered as trusted. And so that's where this notion of zero trust comes from. Zero trust is a concept or an architecture that's coming from Google after they were hacked by China in 2014, 14, I believe. And this idea was that it's not because you're inside that you can do everything. We should consider even the inside of the building as untrusted and put a lot of checks and controls. And the notion of demilitarized LAN is to do exactly that. To do within my building, I have several group of assets, and I should deploy a small demilitarized zone in front of them where I'm going to check who people are, what they do, before they can access my devices, my network. And so you scale that within your building, and there's some elegant solutions to do that. So at the end of the day, it's kind of a full loop, but what we started to say is that IT and OT are kind of different in terms of use cases and technology we're dealing with. But in the end, the way to protect them is the same, is to put some IT, some structure in the network and protection, especially with proxies, back in the play to protect those assets. So to give some concrete example, for example, this is a camera zone. And the way you should think about this in terms of providing access control to my camera. In this case, pretty simple, but basically we have 3 cameras, a recording server. And what we want to say is that my camera can communicate to my recording server. Some users can access my recording server, for example, or my cameras, but that's pretty much it. And everything else is not allowed, not approved. And that's kind of what the business logic that I want to apply on my topology, on my network. And as you can see, it's pretty granular, yet it's really simple to explain that in layman terms. And so when you really think about those zones and who has access to them, then you can kind of reorganize and clean a network that's today much more like you're on the network, you can do pretty much everything. And that's where we really say like what connectivity in a factory should look like is like those are zones that are tied to a business case, a flow in terms of processing, and then you can apply really logic to them, much more than machines or IP. They are like zones, to repeat myself, that allows to create that structure. And yeah, so maybe in terms of implementation recap and what we recommend. So this notion of VLAN for segmentation is not great. And really you should think about VLAN much more in terms of addressing. And that means 2 simple VLAN, one for IT, one for OT. IT has DHCP, OT has static addressing. That's it. And then moving into creating zones based on a business case. Don't use VLAN for segmentation is something I mentioned, but much more like use routing decisions to be able to monitor and give access to different zones or not. And then once you've done all that, you can go fishing a bit in the area. And that's pretty much it. So as I mentioned, strongly opinionated or passionate about building connectivity in factories. So if you have any thoughts, feedback, or you want to chat more about this, don't hesitate to reach out. And thanks again to Julian and the Council of Industry.
Thank you, Florian. This is great. I just have one quick question. So I appreciate you giving your email address and mentioning a couple of times in there that they could kind of contact you as well. But what would it be like for a member firm who reached out to you as a first point of contact? How would that even start?
So once if they should pay an email, depending on what they want to chat about, or if it's just for grabbing a beer. But usually, or the way we engage with manufacturers so far has been to do kind of an audit phase. So it's just to walk around basically the factory with whoever is in charge of the IT of the network, and kind of exchanging of like, oh, why did you do it this way, and do you know about this compliance requirement and the structure? So it's really an exchange at the beginning to understand what has been built, and then from there to build a strategy of, okay, these are the steps that should happen, so that the network is in a better position in terms of structure, performance, and security. That's kind of the goal usually of or what we specialize on. Then
yeah, that makes sense. Something that stood out from your first couple of slides was if it's not broke, don't fix it, that mentality. And that's sort of the opposite of the way this works, right? I mean, a lot of times you probably get a phone call when things are in crisis, and I'm guessing the opposite is best.
It's the ideal world now. Everyone is busy and has like 99 problems to solve. I think networking shouldn't be one. It's something that when you do it on the kind of on the back burner and nicely, you're then in a better position to avoid attacks and just being reactive. Yeah.
That's great. All right. Thank you again, Florian. We really appreciate this, and I hope that people reach out.
Sounds good. Thanks, everyone.
Thank you for watching Inside Exchange, Topics for Manufacturers. We hope you found today's episode valuable. To learn more about the Council of Industry and explore additional resources, visit us at councilofindustry.org.